so sorry about the delay in getting started. I had some issues with second. There we go. Okay, I think I'm live now. I think so. Sure, Victor will let me know. Let me double check just to make sure. We're going live. 6 people. Yeah. Am I live? YouTube's saying I'm live, but I mean, doesn't mean you can see me, right? Alright, I'm going to assume that I am, and look, the video will get recorded anyway, and I'll trim it down to get rid of all of this junk in there at the beginning. Victor's saying that I'm not live, but YouTube is saying that I am live. On the new link. Okay, yeah, I've gone live. So there must be obviously a slight delay. That's all good. So my apologies. I'll put a new link and I've put it on the meetup. And hopefully people get it. If people don't get it, then sorry about that. Yeah, the YouTube Live didn't let me pause the stream and then resume it again. So, echo on my voice. Interesting. I wonder if that's the Sony picking up the sound. That should have fit. I think I've fixed it there now, Paul. If you want to. It'll take a few seconds to come through to you. The voice was being picked up by the Sony camera as well, so maybe the you were getting a reverb, you're getting double echo. So I'll give you a few seconds, and you should be able to confirm that you're not hearing any echo. I always look good, Victor. I always look good. I'm going to assume that the voice is working now because the Sony, the echo's still there. That's an odd one because I mean, there's literally only one capture device, so I don't know why you would be getting an echo. Can't hear an echo on my end. Yeah, okay. I'm going to go ahead and just present anyway. So what I want to talk about right now is obviously CI/CD. That was the original intention, was to look at continuous integration and continuous delivery, and just kind of talk to what it is at a high level. And I can show a very simple demo as well at the end if I've got time. Unfortunately, I do actually only have about 20 minutes now. I did originally only have 30 minutes to actually do this. So I think what I'll do is I'll maybe move the demo to another time. But if anyone wants to say privately, I can do another live stream tomorrow. That's not a problem. So for now, let's just talk CI/CD. Oops, wrong window. So before we talk about CI/CD from the automation perspective, let's first talk about what it actually automates. So it obviously automates manual processes, right? So what do those manual processes look like? Well, what's going on here? Christ almighty. There we go. Effectively, we start with a programmer, right? So we have a programmer, we have a group of programmers initially, and they write software for us. So they write this software, and they may locally write some tests. Two windows on my end, all good, Paul, no problem, mate. So they'll write some tests on their end, and they'll run them. They'll confirm everything works fine, and they'll push their code. And then some developers will pick up that code, or they'll merge their code as well. And maybe something. Well, actually, the actual original goal with continuous integration was actually to continuously integrate code. Wasn't necessarily to continuously integrate tests as well. Originally, when it started out, it was just about integrating multiple developers' code into kind of one repository. That was its original intent, and it's evolved from there. So we have a programmer, and she's written some code, and she's written some tests. She runs the tests manually, confirms everything's fine, and so she pushes her software, right? So, yes, sorry, she's written some tests, she's run those tests, and everything's looking fine. She's got these fancy dashboards. These dashboards are telling her the integration tests look great. They're making sure that all the changes that she's implemented are healthy changes, nothing's regressed and things like that. So everything's all fine and dandy at this point. So once she's written her software, she's written her tests, what she's going to go ahead and do now is she's going to go and package that software. Okay, she's going to package it up. She's going to produce an executable. Could be a tar file. It could even be a Docker container. It could be absolutely anything. But she's going to package that up, and she's going to produce some kind of artifact that will then be pushed over to a systems team, who will then be basically, it'll be thrown over the fence, as we like to say, as operations guys like to say about developers, as they tend to just throw something over the fence at us, and we're kind of just left to work out what to do with it. But we get some kind of executable or some kind of artifact, and then we go ahead and we try and deploy that artifact, right? So the code has been developed, packaged, and has been thrown over the fence. And then we have a systems team. And so the systems team go, okay, well, we've got this package, and it now needs to be deployed across the corporate network. It needs to be deployed across, it's a website, so it needs to be deployed across 3 or 4 web servers. There's a load balancer in place, and then there's various things you have to do: A/B deployments, rolling deployments, canary deployments, etc. There's lots of different ways of deploying, but we're the systems team, so that's our job. That's what we've got to do. We've also got to look at updating configuration. We've got to update data. We've got to look at database migrations as well. So it's possible that the changes that were made by the developer added a column to a database and maybe removed a column from a database as well. So that's a database migration. And so the systems team have to make sure that that goes smoothly, that we have backups, and so we're able to roll back, etc. So the systems team go through these processes all manually, and they put the software in place, and then they launch it. And so off it goes. The software launches, it's off, it's live. All the database migrations have taken place. The software is live and active, and your end users are now using the software as intended. They're clicking buttons, they're filling in fields. Everything seems to be working as expected. Everything's all great. And then we're back to testing again. So we've deployed our software. It's now live. People are using it. So what we do now is we start looking at the metrics, right? We start looking at graphs and metrics. Hopefully you've got them. You start looking at logs, and we start basically almost at the edge of our seat. We're kind of just hoping that everything worked as expected. There's no errors that have creeped in that we didn't expect to see. We're not seeing a drop off in users. If we have 100 users at any one time, it's now, why is it only 10? We're not seeing 1,000 users. Well, that's odd. Why would we now have 1,000 users? They do all the migrations that are necessary. They deploy it, they make it live, and then we sit there and we watch and make sure it works. And once we're happy after a few hours, we go home or move on to the next task to go through. So say for example, we're producing an executable that implies some kind of compiled language. Okay, or maybe if it's .NET, it's like a JIT based language or something like that, which is essentially still compiled. And so does the developer sit there and just watch it? Does the developer just sit there and actually just kind of watch it build? Now, how long does that take? How big is this executable? And what about the deployment itself as well? How long did that take? How long did the deployment take? Did the systems team just put an executable on a file, restart a service, and then they just sit there and wait for it and just watch it? Or did it take 2 hours or 3 hours? Manual deployments tend to take quite a while, especially when they involve database migrations, because database migrations are very, very sensitive. If you get it wrong and you need to roll back, that it isn't of itself, rolling back a database migration is also a big job. And CI/CD in an automated fashion, which we'll discuss next, not particularly after this slide, but in a few slides' time, doesn't necessarily allow you to solve database migrations. You may get to a point where you can. There's still a hard problem to solve. But the point here is that these manual processes, the question you've got to ask is how long do they take, right? And then the next problem is, what happens if they actually did did break something? What happens if we did introduce a problem, but the tests themselves didn't pick up the problem because there wasn't a test written, or the tests weren't written correctly in order for them to pick up this problem? What if there was a regression, but you just didn't have sufficient tests? What if the developer forgot to run a particular type of test? What if the developer said, oh, this is taking too long, let's just skip this. Let's just skip this test. Let's just move on beyond this test. That's not good, right? Because, I mean, once it's gone live, if the test's been done incorrectly, or you've introduced a regression, some kind of faulty software, or you just got bored and skipped a test, or it was an emergency patch, for example, is a good one, a hot patch, what happens then in production when things go wrong? Because you've done everything manually, you've then got to, the assumption is that you've got to roll back everything manually. And how do you do that rollback? Do you snapshot VMs? That takes time. VMs have to come up. It's a difficult question to answer. Okay. Essentially, the biggest common factor around all of these processes, actually. So the big question here is, when we talk about the manual process and we talk about all of these problems that can arise, you've got to then ask the even bigger question of, what is the common factor between all of these manual processes? What is the one thing that is persistent between each of these manual steps? What's the one thing that's always present, right? And it's people. People are present throughout all of those processes. We can't yet, I'm sure within a few decades, AI will be writing our software for us, but at the moment we do need our people to write. We need people to write software for us. But ideally, we want to remove people from as much of the process as possible. We want to expunge people from the process, right? We want to get them doing other things. We want to get them doing things that we can't automate, which eventually will become automatable. So for now, in our manual scenario here, we've just got people everywhere. And the problem is that people get tired, people get angry, people get lazy, they get emotional, they just can't be bothered doing things sometimes. Perhaps a process or some kind of new way of doing things just doesn't get communicated to them, or they ignore the communication, or they don't agree with the change, and so they're stubborn and they refuse to implement the change in that way. And so you've now got this person that's now effectively a bad actor in the whole pipeline, and just doesn't do as instructed, thinks they know better, or maybe just didn't get the email. And so there's just lots of different things that can break when the pipeline is manual, and when the pipeline is manual and effectively relies on people. So effectively we've got this problem of people are vulnerable, and it takes a lot of time. So people are essentially why we do burn through so much time, because people are much slower at doing things than with computers that computers can do themselves, obviously much quicker. Computers are literally calculators. That is literally the point of them, and they can do those calculations much quicker than we can with our clunky with our clunky UIs and our mouse that we move around and click on things and type our commands manually. Once you've written those things once, that very, very slow user, that person, is then taken out of the picture. I'm just a bit weary because YouTube Live is telling me that it's not receiving enough video to maintain smooth streaming. So just let me know in the chat if you're getting like stuttering and things. I'm not really sure how I can fix that. I'd have to reset my streaming settings, just lower the bitrate, but I set it to the bitrate it recommended. So I apologize if it's skippy. I do actually have a pre-recorded video of this entire presentation that I did for a commission for Chester University in England. So if necessary, I'll put that up on YouTube. Oh, in fact, it's actually up on my Podia. It costs $10, but I'll put a voucher up for people within this meetup so they can grab that for free. So effectively, we're at this point where in this scenario here where we've got people, they're doing things manually, things can break, they're slow, and they may just choose to not do things. All good. Thanks, John. So what's better then? What's the next step? So the step is obviously to automate those things. The best thing you can do The last 5 minutes. Okay, cool. The best thing you can do is automate away these processes. So what does that look like? What happens if we actually automate those processes, and how do we automate those processes? So let's start with the question, how do we automate those processes? And the answer is actually quite simple. It's robots. We basically write robots. It's effectively what we do. We write CI, continuous integration jobs. We write continuous delivery jobs. And those jobs are small little chunks of code that do something specific, such as compile code to an executable, build a Docker container, run Terraform, run Ansible, run Go test commands, and so on and so forth. And once they've been written, they are like little tiny robots that just repeatedly do that thing over and over perfectly every single time, unless you've introduced a problem within that code. Computers basically just do what they're told. So that is effectively what continuous integration and continuous delivery attempts to be. Is basically an engine or a platform on which you can install all of these little robots, or design and build your own little robots that do all these tiny little tasks for you. So what happens if we go back to the beginning that we had earlier, okay, where we had our program, and we go through that entire process again? What does that look like if you actually automated CI/CD? So if we go back to the beginning, we still have our programmer, right? She's still developing software for us, but this time what she's doing is she's writing code to the best of her ability, and then she's writing some form of tests to test that code. And she's also probably running a test locally as well. A good programmer will run tests locally if it's applicable and if it's a sensible thing to do, i.e. time-wise, it doesn't take like 3 hours to run all of the tests, or she might run a specific subset of those tests. And because you want to try and catch things before you're actually pushing to Git, so you're not wasting people's time. But let's assume that our programmer here has written some code, has written some tests, has run them all, and everything's fine. So what happens next? So she's then going to push the code to GitLab or GitHub or Bitbucket or Azure DevOps. She's going to push it to some kind of remote Git repository. And from there onwards, she can literally, if she wants to, she can literally just go and get a cup of coffee, or move on to another task, or go home, or go for a walk, or go for lunch. Because the idea behind CI/CD is that it removes the people. So at the end of the previous set of slides, I said the people are the major bottleneck and the major problem with these processes, and so we're now removing the person. So what does that process now look like? Well, if you remember, the first thing that the developer did was they ran some tests locally. Well, once you've pushed to your CI/CD platform, the business, quite frankly, it doesn't trust that and shouldn't trust that you've ran the tests. It shouldn't trust that you've ran A, all of the tests, B, ran all of the tests to completion, the right tests, or that the test even passed. You could have missed a failure in a test. One of them could have failed, but it could have just scrolled right past you on your screen, and you just saw a load of green and went, great, that worked. So the business shouldn't actually trust that you ran the tests properly. So the first robot that we write is our continuous integration robot, and this little dude is going to basically run all those tests for us each and every time without fail from start to finish. And if one of them fails, the pipeline fails. And so tests are effectively a way of the business saying, this software that you've written does not meet our expectations. And so the first robot is ensuring that all the tests are being done, none are being forgotten, and when they fail, the whole pipeline fails. And so that's our first little robot. The next robot is now been given this code and been told everything's fine, all the tests run, and we're confident in our tests. We're happy that the software meets business expectations, so go ahead and deploy. So this little guy here is actually going to, not deploy, but package. This little guy here is now going to package it. So if we say we're going to build a Docker container, this little guy is going to take the software, he's got a Docker file in the repository, he's going to run Docker build, he's going to work out what the latest tag is, what version should this be, where am I going to get the version from? I'm going to get it from that database, or perhaps it's inside of the commit message in some way. So this little dude's going to go and grab that information, he's going to build a Docker container, he's going to tag it with that version, and then he's going to push it to the repository, to the registry. And you'll notice that so far there's not a single bit of human intervention. This is all work that's been done ahead of time and has now been left to run. So there's no humans at this point. And then the next, now we've gone from continuous integration to continuous delivery. This little dude is now going to go, well, I've now got a Docker container. It's a higher version than the last one. I've been automatically triggered by my mate, that previous robot. And he's told me that this container is everything you're going to need to deploy. You're going to need to deploy this live, make it live on the network. So here it is. And this little dude's going to take it. He's going to go off to, it could be Kubernetes, could be Mesos, could be CoreOS. It could be whatever. And he's going to say to it, here's a new Docker container. Let's make this one live. Let's do a rolling update. Let's replace 10% of the servers and roll through, or let's do a blue-green deployment, and so on and so forth. And we're going to do that in dev, or we're going to do that in test, or even production if you feel I'm really confident. But this little guy is going to handle all of that for you. And it could even be really, really, really manual. It could be, this guy could be running Terraform. He could be running Ansible to configure the operating system. It could be really old school way of deploying. You could be unrolling a tar file over the file system and then starting a service and then clicking your load balancer over to the new server. It could be a really clunky older way of doing it versus what we have with containers today. But the key point here is that it's the robot that's doing everything, and the human has now been removed completely. So the deployment's gone ahead. None of the tests have been skipped. It's been built correctly. It's been deployed correctly. So now we have to monitor, right? Well, you can build a robot for that as well. Because essentially, any dashboard that you create, any kind of graphs, bar charts, anything like that, these kind of things are being rendered from quantitative data, right? That numbers basically, except for like log files. All of these graphs that we can see here on the screenshot behind our little dude here, like the 57.1% that's highlighted in the top left, it's just a number. And what is it the computers are best at handling? It's numbers. Far better at handling them than we are. So even the monitoring can be done automatically as well. Even the monitoring, our little robot here can run an entire monitoring suite and just basically sit there and start poking it and expect, do I get 200 OK from this endpoint? Actually, I should get a 404 if I go to this endpoint. I do. Okay, great. So no one's introduced that page. It's not meant to be introduced yet, for example. Is the database performing? Is the CPU gone up? How many users do we have? What are we expecting? What's low and what's high? And so all of that can be automated as well. And then once that's actually finished, you can then have your little robot just shut down, and then normal monitoring takes over, and normal monitoring practices take over. And at this point, there's been no human whatsoever. The human's written the software, has then pushed the software, and then there's been no human being at any point along the pipeline. Right? There's just been a robot across the entire pipeline, which is awesome. It's exactly what you want. You want to remove the people who are well, I don't want to say they're wasting time. They're obviously just doing the job. What I mean by wasting time is that they take much longer to do these things manually than a computer will be to do the same tasks. If you picture a bash script or a PowerShell script with 10 lines of code in it, and you've got to type them out every single time, well, or you can just type them once and a computer will run them like that, just run them instantly, right? So it's much quicker at doing these things. Hopefully that makes sense. So effectively, this is what the pipeline looks like, right? This is the automated aspects of the pipeline anyway. You'll notice the slide isn't in there with our programmer. So these are the steps that relate to our robot: our testing, our packaging, our deploying, and then our testing again, testing the live deployment to ensure that it meets business expectations. And everything there, every step is fully automated, and the whole pipeline is fully automated as well. That is everything done by a robot, which is sweet. And the reason this works so well is because, like I said earlier, if those first initial tests don't pass, the robot doesn't do anything else. It doesn't say to the next robot, everything's gravy, go ahead and deploy, package, go ahead and deploy. It's not gravy at all. It's garbage. It's broken. There's been a regression. Something's gone terribly wrong, and we need to actually now back away from this deployment, and the developer needs to be told, go fix your code. So at that point, the developer will indeed go away, fix the regression, run some more tests locally, push, and then once that's done, the pipeline will pass, and then we'll go back through the pipeline again. And so it catches mistakes as well. It's not just about the one programmer. It's catching everyone's mistakes. It's preventing all this work from going through. Everyone's pushing code all independently. That's the point of Git. It's what it's designed to be distributed. Everyone's working independently. They're all pushing code, and the business wants to know: is this stuff that you're pushing, is it viable? Can I use it? And that's what this pipeline is doing for you, completely automatically. Right, what's this slide for? Why have I got this one with the full? Okay, so this is the story that I've effectively just told. So essentially, the developer's written some code that's faulty. We've started the process. We've failed the process, and essentially the code ends up back here. So we have our failure of a pipeline, and what essentially happens is our robot friend here then lets this developer know your code didn't succeed. It wasn't. I'm not happy with this code. It doesn't meet business expectations, and so we need to not deploy this, and you need to fix it. Here's the error I got, and it can even report on the actual error that I received. And eventually the whole CI/CD cycle starts again. Goes back to the human. The human does their thing. That can't be automated. They push it into the pipeline, and then the whole automation kicks in. So at this point, I would go into a demo, but unfortunately, I've run out of time, and that's purely on me, and I apologize for that. The demo would just be using a simple. I can show you the actual. Hopefully, this works. So I can show you the actual code, but I can't show you the run because I can't get into the GitLab system to show you. But if we look at my example Go code here, all I've done is written a really, really simple function that essentially just says, take an argument on the command line, and if there is no argument, then just say hello, or at least call this function with the word stranger. Down here, I'm just saying if there is a command line, then just bounds check it. Make sure it's no larger than 12, and only use the first 12 characters. We've got our bounds check here. Really, really simple piece of code. If the length of the string is greater than the bounds check, then just return the first set of characters that are bound by that bound check, and then we just print it to the screen. So pretty simple. If we look at the tests that I've written for this, so we've got test bounds check with table, and we've got a simple table here of the value that I'm going to key, the bounds check that I'm going to provide, and the value I expect to see. Obviously, with a bounds check of 12, if I key in Mike, I'm going to see Mike. If I key in this set of numbers here with 12, then that 3 at the end there should be chopped off. Okay? And so on and so forth. And so if I just run a Go test, we can see that these tests all pass at this point in time. But if we look here, I'm running that same command there, right? So this is the GitLab CI file. This is the YAML file that tells GitLab. The top line there basically says, go and get the Golang latest Docker image. Go download that. And then all I want you to do, this is a very, very simple Git CI/CD file. All I want you to do is just run go test -v, which is verbose, against the repository. If I do go test without the v, you just get a simple, yes, everything was fine. But if you want to look at every individual test, then there you go. And what we're seeing here is that go test -v command being automated. Now, this is obviously a very contrived example. It's a very simple example. But that's just one command that will probably, if I was to expand this out to be a full CI/CD pipeline, this would become tens of lines, easily like 40, 50 lines, building images, testing things, especially for a very large software suite. If you're running things like microservices, then these files are probably all going to be very small, because you're going to have individual repositories for every microservice, and microservices are, hence the name, micro, they're small, and so there's not much going on in there. So you might still have a lot of tests, but the whole CI/CD pipeline for a micro container is going to be much simpler and more straightforward. than a monolith that's 10 years old, written in Ruby Rails or something. So that is pretty much what I wanted to show. So I'm happy to take. I've got a few moments I can spare. I'm happy to take some questions on the live chat, if anyone has any, and I'll do my best. To answer them. Of course, there's a bit of delay here as well, so it makes it really difficult to actually answer. I have to kind of wait for the questions to come in and then sit and stare at the camera, sit and stare at the screen, and wait for them to come in. But hopefully you're still there, and hopefully someone has any questions. I apologize that the link changed. I had an issue with my microphone, and I attempted to pause what I thought was pausing the stream, and ended up ending the stream. So unfortunately, the actual link changed. So I'm sure there'll be some angry comments on the meetup. But like I said, I've got this presentation pre-recorded anyway, and in much more detail, much longer as well. The entire thing is it's about 45 minutes with the demo, and to be fair, we're at about 30 minutes now. But there was a lot of faffing around on my part. Well, look, I'm not seeing any questions come through, so I'm gonna call it a day there. Thanks very much for coming along. Obviously, with the virus at the moment, we've got to isolate ourselves, and this is obviously a little bit further than 1.5 meters. For some, it could be 15 kilometers. Actually, a question has just come through from John Jesberg. What about gates to determine whether something should be deployed to production? Even if it passes all tests, may not want to deploy to production. Yeah, that's right, John. Yeah, that's absolutely correct. They're called manual gates, and a lot of companies do that. A lot of companies don't trust that the tests are quite sufficient. They still want that human intervention, and in some environments it's probably a good idea, and in others it wouldn't work. So for a lot of the environments I work in, which can tend to be quite large, it doesn't tend to work. A friend of mine called Brandon, who works in the US, he works in scales that, in fact, he's just left a company, an advertisement company, who were in the top 5 of Google Cloud's customers in terms of expenditure. That's how big they were. They had tens of thousands of servers, of virtual machines. There was a massive array of Kubernetes clusters all over the show. You couldn't have manual gates on their environment because of the nature of the software, because of the nature of what it does. They can't afford manual gates, because you're talking about, if I remember rightly, nearly 1,000 microservices running in that advertisement space for all of these various networks and advertisements and different ways of delivering adverts and collecting statistics and all the stuff that advertisers do. It's not actually possible for him to have a manual gate at all. He can't. It's just not an option. Whereas if you've just got, if you run I don't know, some kind of web app that just sees a couple of thousand users a day, it's just a load balancer with a couple of web servers. You have a prod, you have a staging, and you have a dev. Then you probably can afford to just have that manual check, and a lot of companies do actually do that. Good question. Well, I think that's probably it. So thank you very much. What I'll try and do is get some suggestions on maybe something you want to see for next month. I'll create the meetup entry for next month. What is next month? What are we in? May? Jeez. So May. So it'll probably be this similar Tuesday in May. So we'll probably be looking at Tuesday the 2nd of May, probably. It will probably be virtual again. Don't know how things are going out there with the virus, or what the government are going to do. I reckon probably for the next 3 to 4, maybe 5 months, probably need to be a virtual meetup. But hopefully that was helpful. Thank you very much for coming along, and good night. You're welcome, Victor. You're welcome, Peter, Paul, John. You're all welcome. Thanks very much.